in the last video we covered the start of the basic concepts of Cogent Core, and in this video we're going to continue with value binding plans and asynchronous updating. So on the last page we showed you how to directly update the content of widgets. On this page we're going to show you value binding, which is a way that you can automatically update the content of widgets. So you can see here that we're calling core.bind, which binds this variable count to this text widget. And so that means that the text is always going to be the same as the variable. It's going to represent the variable. And so you can see that this has the same effect as the updating examples on the previous page, but with less code because it's automatically binding the value and doing the updated logic for you.
And different widgets have different kinds of data values that they can have bound to them. A text widget, because it represents strings, can represent anything. Anything can be turned into a string. But we could also use a spinner here, which represents numbers specifically, and you'll see examples of that as we go through.
And so you can see here that updating with value binding goes both ways. So this switch is having its value set from this bool variable, but then when you click on the switch, it's also updating the bool variable, as you can see here. And so value binding is a really powerful two-way tool that allows you to keep widgets in sync with the values you want them to represent.
And overall, this approach of binding and representing underlying Go data values is a really important property of the core framework. We leverage this in many ways throughout the code base in order to make it a lot easier to just focus on the data and the logic that you want to code for your specific app. And then this automatic binding allows the GUI to simply represent, the underlying data values without any extra work on your part. It can also represent a struct as a form, like a whole data form, and so you can actually fill out like entire database kinds of applications just by creating the underlying data structures and using this bind mechanism to represent that data. And again, because it's bidirectional, you automatically get the values that people enter into the form, etc.
Okay, so we just covered how you can update the properties of a widget, but what about updating the structure of a widget itself, the children of the widget, what's contained within it? For that, we provide plans. So you can see here that we're using a maker to make a plan for how this widget down here should be structured. So this is a container, and we're putting buttons in it corresponding to this number from this spinner right here. And so this basically says that based on this number, we're going to make that many buttons inside of it, and it will automatically, dynamically update to whatever number you put in using this plan structure.
So the overall idea is that instead of actually creating all the widgets, every time, as is what happens in a declarative paradigm used in many different GUI frameworks, instead we make this very lightweight plan that just specifies, well, if we need a new widget to be made based on the unique name identifier, then it will call this closure function that we define there in the add function that creates the widget itself. And so this is much more efficient than redundantly making a whole set of new buttons when in fact most of the time nothing is updated and you don't need to make a whole new thing. And so this is a much more efficient way to also be very flexible and powerful in adapting to the need for changing content as your data structures change in the underlying app.
Most of the time when you're writing code in Cogent Core, you don't need to do any special locking or asynchronous updating steps because you're just updating through the main event loop. But in the case that you are using a separate Go routine to update things, then you do need to call these async lock and async unlock functions. But that enables you to really take advantage of Go's concurrency features. And so you can see here that we're making this text, and then we're making it so that the text of the text widget is updated every second to the current time. And so we have this encapsulated updater once again, and then we're just using a separate Go routine using these asynchronous functions, and then all we have to do is call update, and it updates automatically.
Great, well that covers everything in terms of basic concepts. You'll see as we go into our next video covering the tutorials for a simple to-do list and the tic-tac-toe game, how we take these basic concepts and combine them to make simple applications.